Good evening. Welcome to the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and I'm going to talk about a subject that I call it a go-between. Now, some call it cost engineering, cost accounting. Well, when you're dealing with projects, whether it be construction or manufacturing, you're going to have some fixed costs and some variable costs. So, what some people call cost accounting, we can also call it engineering economics, where you deal with future worth, present worth, capital, because you need to know some type of accounting to make sure that your books are straight. Now, I'm going to go ahead and share my screen, and I want to talk about the fundamentals of cost accounting. This comes from textbook chapter 5. Now, very important because this is going to show you some costs. Just bear with me here. All right, here we go. So, we're going to deal with cost estimation. Now, last week we dealt with quantity surveying. Well, you can actually put cost estimation in there with quantity surveying as well. And the objectives, you want to understand the reasons for estimating fixed and variable costs. You're going to estimate cost using engineering estimates. You're going to estimate cost using account analysis, statistical analysis. You're going to utilize the interpretation of regression output. You're going to use regression data to identify potential problems. And what are the advantages and disadvantages of alternative cost estimation methods? Then, of course, you can utilize the spreadsheets and mathematical relationships with cost estimation. Now, why do we estimate costs? Well, if you are working for a contractor or even working for a company and you're a manager, as a manager, you must make decisions because you have to compare costs and benefits with alternative actions. So, what does the cost estimate add to any value of a contractor or firm? Well, cost estimates can be an important element because, again, it's going to help managers make decisions. Now, you must understand the reasons for estimating fixed and variable costs. Okay, now, as you see, you have costs, and costs are divided into fixed costs and variable costs. Now, when we talk about fixed costs, they're basically costs that do not change proportionately when activity and as activity changes. And they're per unit fixed costs because change inversely as activity changes. So per unit fixed costs change inversely as activity changes. So what does that mean? Again, your costs don't change, but your activities change. Now, when we go the other way and we talk about variable costs, well, total variable costs change proportionately as well and with activity. So when it comes to fixed costs, costs do not change, but activities change. But variable costs, cost and activity change. Now, as we talked about fixed costs change inversely, stays put, or costs change inversely as activity changes. That's per unit fixed cost. Now, per unit variable cost, they remain constant as activity changes. So if you look at everything, on the flip side, fixed costs, they change inversely when activity changes, but variable cost remains constant. However, activity changes. So let's talk about an example. Charlene, owner of Charlene's Computer Care, 3C, wants to estimate a cost of a new computer repair center. So we're going to come down to three methods: engineering estimates, account analysis, and statistical methods. So when we deal with estimating costs with engineering estimates, they're based on measuring and then pricing the work involved in a task. So you have to identify the activities that will be involved with engineering estimates. So when it comes to engineering and building, three important things you must understand: labor, rent, and business. And you also have to estimate the time and cost for each activity. Advantages. And the advantages are: it details each step required to perform an operation. It permits comparison of other centers with similar operations. And costs for totally new activities can be estimated without prior activity data. Now, of course, with advantages, there are also disadvantages when it comes to engineering estimates. Engineering estimates can be quite expensive to use, and it's based on optimal conditions. Now, what about utilizing the account analysis method? Well, you have to review each account comprising the total cost that's going to be analyzed. And you must identify each cost as either fixed or variable. Now, going back to this example again, as we go into the account analysis method, 3C cost estimation using account analysis. Now you see what you have here. You have all of your accounts, and then you have your total. Now, how did I get the total? Well, basically, I'm adding my fixed cost and variable costs. That's how I get my total. Now, basically, using the 3C cost estimation method, you're utilizing your fixed cost plus your variable cost, and you're dividing it by the unit times number of units, and that equals your total cost. Like again, when we had the cost at 360 repair hours, here's all the information for that. Now, with the account analysis method, the advantages are: managers and accountants are familiar with company operations and the way costs react to changes in activity levels. However, the disadvantages are the managers and accountants may be biased. So decisions have major economic consequences for managers and accountants. Now, we get into our third method, and that's statistical cost estimation. And basically, you utilize a relevant range, which is the limits within a cost estimate may be valid. So basically, Relative range for a projection is usually between the upper and lower limits, or we call them bounds of past activity levels for which you have available data. Now, looking at the information, the overhead cost estimation for 3C. Well, you have A, B, and C. You have your months, your overhead cost, and your repair hours. Now, this data on a spreadsheet is going to be used to estimate costs by way of statistical analysis. And also, when you're doing statistics, you have to understand the relationship. So, in this graph, does it look like a relationship exists between repair hours and overhead costs? Well, in order to find that out, you must know how to interpret the data and what this data is involving. It's manufacturing overhead. And if you look at the plot of this graph, it's called a scatter plot. So if you look at everything, you have some points that are on the line, some are barely off the line, and some are way off the line. So what happens is we're going to use, I call it naked eye, to determine the intercept and slope of the line. Then we get into high, low cost estimation. Now, this is a method to estimate cost based on two cost observations, the highest and lower levels. You get the month, the overhead cost, and you have the repair hours. Now, basically, when we deal with high, low cost estimation, we have what we call a variable cost per unit, which is your cost at highest level minus cost at lowest activity level. And that's divided by the highest activity level minus the lowest activity level. Again, variable cost per unit is going to be capital V, and that equals cost at highest activity level minus cost at lowest activity level. Then you're going to divide all of that by highest activity level minus lowest activity level. Then you have fixed cost, which is the variable F, and that is the total cost at highest activity minus variable cost times the highest activity level. Or it's total cost at lowest activity minus variable cost times lowest activity level. So let's put some numbers in. Well, when you put numbers into the formula, this is how you come up with all of the information that was required from the formulas. So, how do we estimate manufacturing overhead with 480 repair hours? Take a look at the formula. Total cost, your capital F, is your fixed cost plus variable cost. And what is X? X is your repair hours. That's what X is. So what you're going to do, you're going to take total cost, and that's going to be that's plus your fixed cost. Actually, your total cost equals your fixed cost plus your variable cost times your repair hours, and that's how you get the total cost. This formula is very, very self-explanatory. And again, cost accounting is very important because you're going to see a lot of it when you deal with engineering economics. Now we get into regression analysis. It's basically a statistical procedure to determine the relation between variables. So it helps managers determine how well the estimated regression equation, and it describes the relations between cost and activities. So basically, what you're doing when we deal with regression estimation, there's an equation. We're just looking at the relationship between cost and activities, and it's going to help managers determine how well the regression equation works. We're going to use the high-low method. That's using 2 data points, and regression. Regression is the use of all data points. Now there's an equation. You have y equals a plus bx. Now, if you've taken algebra, you've seen that equation. Y equals mx plus b. Well, you're using slope. Well, the same thing is accounted for here. The equation is manipulated. However, must remember, b is your slope. Just like if you were using y equals mx plus b, m is your slope. Well, a is your intercept, b is your slope, plus x. Now for 3C, overhead, fixed cost, plus variable times repair hours. Now what we have here, we have an independent variable, the X term or predictor. Now the activity that predicts is causes, which is the change in cost. Then our activity, that's repair hours. Now our dependent variable is the Y term, the dependent variable and the cost to be estimated. And then we have for cost, overhead costs. Now we're going to interpret regression. So the computer output of the 3C's scatter graph gives the formula overhead. And it also gives you the 3C's. First one gives you that slope equation. Well, actually, the second one gives you the slope equation. The first one gives you the overhead equation. Now we're going to get into how you interpret regression. Well, this measure called correlation coefficient, what it is, it's a linear relationship between variables. So the closer R is to 1.0, the closer the points. We're dealing with close points. So basically, the closer the points are to the regression line, the closer R is to 0, the poorer the fit of the regression line. Then we get into R squared, which is the coefficient of determination. And what that is, it's the square of the correlation coefficient. It is the proportion of the variation in the dependent variable Y explained by the independent variables X. And a lot of this, I'm just giving you theory right now. You can utilize calculators and spreadsheets. Now you have the T statistic. This is the value of the estimated coefficient B divided by its estimated standard error. Generally, if it is over 2, then it is considered significant. If significant, the cost is not totally fixed. Now, from the data used in the 3C regression, tells you how you get your T statistic. Plug and chug. You understand the formulas. The math is very simple, but you still have to learn how to interpret the data. Now, when we get into interpreting regression, a number such as 0.91 correlation coefficient means that a linear relationship does exist between repair hours and overhead costs. Now, 0.828 coefficient of determination means that 82.8% of the changes in overhead can be explained by changes in repair hours. Now, how did I get from 0.828 to 82.8%? Very easy. I multiplied it by 100 to give me the percent. So when you look at everything, again, you're dealing with a relationship between repair hours and overhead costs, and changes in overhead costs explained in repair hours. So both T statistics that are greater than 2, so the cost is not totally fixed. And we also deal with multiple regression. That's when more than one predictor, X is in the model, is repair hours, the only activity that drives overhead cost at 3C. You can see your predictors and you can see the equation. This is also good for economics as well. You'll definitely see this equation in economics. Then we deal with the multiple regression output. That's where we have the adjusted R squared, and that is the correlation coefficient squared and adjusted for the number of independent variables used to make the estimate. Again, the adjusted R squared is the correlation coefficient squared and adjusted for the number of independent variables used to make the estimate. So what you have here is the statistics supplied, but the output rounded off are, they're giving you the correlation coefficient. They're also squaring the correlation coefficient, and then you're going to get your adjusted R squared. And here are some more equations. You have your fixed variable cost, your variable cost, your total cost. Now, with every theoretical mathematical problem, you're going to incur problems. So, identifying problems with regression data could be outliers, nonlinear relations, spurious relations, and using data that does not fit the assumptions of the regression analysis. You can look at the graph right here. You have different functions, volume, cost. You have the effect of nonlinear relations. Problem, attempting to fit a linear model to nonlinear data, likely to occur near full capacity. Solution, define a more limited, relevant range, example from 25 to 75% capacity. Then you got to design a non-linear model. And you see the scatter plot. We're dealing with overhead costs and machine hours. This is the effect of outliers on the computed regression. And the problem, outliers move the regression line. So what do you have as a solution? Prepare a scatter graph. Again, you have to prepare a scatter graph, analyze the graph, and eliminate highly unusual observations before running the regression. The effect of spurious relations problem, using too many variables in a regression, i.e. using direct labor to explain materials cost. So although the association is very high, actually both are driven by output. So what is your solution? To carefully analyze each variable and determine a relationship among all elements before using in the regression. Then we get into the effect of using data that do not fit the assumptions of regression. Problem. If the assumptions in the regression are not satisfied, then the regression is not reliable. Solution. There is no clear solution. Limit time to help assure cost behaviors remain constant, yet this causes the model to be weaker due to less data. Learning phenomena is a systematic relationship between the amount of experience in performing a task and the time required to perform it. Advantages, and this is how an estimation method is chosen. Your advantages are reliance on historical data is relatively inexpensive, while computational tools allow for more data to be used than for non-statistical methods. Again, reliance for the advantages, reliance on historical data is relatively inexpensive. Computational tools allow for more data to be used than for non-statistical methods. Disadvantages, reliance on historical data. Again, reliance on historical data may be the only readily available cost-effective basis for estimated costs. Disadvantages again, reliance on historical data may be the only readily available cost-effective basis for estimating costs. So analysis must be alert to cost activity changes. We get into data problems. Missing data, outliers, allocated and discretionary cost, inflation, and mismatched time periods. Effect on different methods on cost estimates. And this is estimated manufacturing overhead with 480 repair hours. See the method. You can see the total costs that are estimated fixed cost, and the variable costs. And again, I've dealt with statistics before, and if you don't know anything else, many software programs exist to aid in performing regression analysis. Now, in order to use Microsoft Excel, there must be analysis tool pack installed with your spreadsheets. And what happens is data is entered, and then the user then selects the data and type of regression analysis to be generated. And the analyst must be well schooled in regression in order to determine the meaning of the output. And you must understand the mathematical relationship describing the learning phenomenon. And this is a systematic relationship between the amount of experience in performing a task and the time required to perform it. And you see the information that I have here. Basically, you have impact. It causes the unit price to decrease as production increases. And that is the end. And what I talked about today when it comes to cost accounting, you may think of it as, is this engineering? It is involved with engineering and business. And I'm going to tell you where this method fits perfectly. If you are doing industrial engineering, this is where you're going to deal with a lot of business and engineering put together. That is the good thing about industrial engineering. You're going to use a lot of statistics in industrial engineering. And cost accounting and cost estimation is big in industrial engineering. Because one thing about industrial engineering, which is a lot different than your civil, mechanical, and electrical engineers, you're really taking a system and looking at everything as a whole. Whereas the others, You're taking parts of a system, you're designing it to get the whole. So you're dealing with industrial engineering, you're dealing with statistics, you're dealing with production control, you're dealing with facilities, you're dealing with fixed and variable costs, man hours. You're dealing with queuing, ERP. You're dealing with making decisions. So you're going to have to understand spreadsheets. And statistics isn't easy for everybody. But if you understand the formulas and you understand how to interpret the data, the relationships, you can become a good manager. Now, a lot of this information that I provided to you is theory, but you need to understand the theory. Now, if you are in industrial engineering, and let me go one step further, because a mechanical engineer or an engineering manager can also work in industrial engineering. So you're going to have to understand project management as well. That's big in industrial engineering. This is why industrial engineering, and you can say mechanical engineering, industrial engineering is really a breakoff of mechanical engineering. You can basically go into any engineering discipline. While mechanical engineering, some people say, well, can you do construction? You can do structural engineering for mechanical engineering, but you're going to have the concepts of engineering management, operations management, cost accounting. You're going to deal with cost estimation. You're still dealing with projects. You're dealing with budgets. You're dealing with fixed costs, variable costs. You're dealing with materials. You're dealing with laborers. You're dealing with scatter graphs, histograms. You're dealing with data. And you have to understand the data if you want to make good decisions. But what I laid out to you tonight was an overview of cost accounting or cost estimation. And again, I'll be posting this video up in my on my Twitter and my LinkedIn page. So check it out. This is good information, particularly if you're going into engineering management and industrial engineering. That concludes this topic on cost accounting. If you like what I just presented, please comment, share, and subscribe. And if you're looking for some political and social content, check out my main channel, the 411 Talk Zone radio show. Now, after I record videos on both my channels, the 411 Talk Zone radio show and the QCIS channel, same videos will be posted on my Twitter page. Now, for the QCIS channel, I take it one step further. Since it is educational content, you will find information from the QCIS channel also on my LinkedIn page. Once again, thank you for viewing this content from the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you to have a wonderful and gracious evening.